All right, so we're going to look at some single replacement reactions. Now, your teachers have probably taught you that for the alkali, for the halogens, the group itself is the activity series. So fluorine's more reactive than chlorine, chlorine's more reactive than bromine, bromine's more reactive than iodine. Okay, so your teachers may not give you that. You know, your teachers have given you activity series of metals. They may not give you the activity series of the halogens because you have a periodic table. Okay, so how do we like show that? So here's I have something set up that demonstrates the reactivity of halogens pretty nicely. So I have in this first test tube cyclohexane and iodine. I just want you to know that cyclohexane is purple when iodine's dissolved in it. This is bromine dissolved in water, so it's an aqueous solution of bromine. So bromine does dissolve in water by what's called dipole-induced dipole. And then we have a solution of potassium iodide, all right? So these are our controls. So what and in this test tube, I have some cyclohexane. It's colorless, clear and colorless. So what I'm gonna do is in this test tube, I'm gonna add potassium iodide and bromine. So let me put a little bit more potassium iodine. I just thought of a better way of doing this. Put a little more potassium iodine in here. Okay. And I'm gonna put a little more bromine in this one. So we're gonna react, we're gonna pour in the aqueous of bromine into this test tube that has some cyclohexane in it. Let's pour a little bit of this in, and let's pour a little bit of this in, and then we're gonna shake it up. Okay, so you can think about what are you gonna see? What are you gonna see when I show you this? Well, you know the cyclohexane's nonpolar, so where is it gonna be? Hey, you can stop it. This is the result of the bromine reacting, the aqueous bromine reacting with potassium iodide. And you can see that the cyclohexane's purple. So that implies that iodine's dissolved in the cyclohexane. So iodine got the boot in this case. So it tells you that bromine is more reactive than iodine. It confirms that since bromine is above iodine, that it's more reactive. If we did it the other way around, it wouldn't work. So think about, you write the balanced chemical equation, bromine, Br2, remember it's Hofmankel, plus potassium iodide, and you think about what the reactants are, okay? But that clearly shows that there's some iodine, I2, it's a Hofmankel, dissolved in the cyclohexane, all right? All right, activity series of halogens.